A specific type of rate of change is called a slope, and slope is the rate of change that we look for when we're looking at a graph. So one way to determine the slope of a graph is to count rise over run. So think about what we learned about rate of change. Rate of change is change in y over change in x. And think about when you graph y, you're graphing vertically up and down. That would be the rise. And when you graph x, you're graphing side to side. That would be the run. The way that you can tell the type of slope on a graph, when you read the line left to right, the same way we read a book, if the line is rising, the graph has a positive slope. If the line is falling, it has a negative slope. If the line is going side to side, horizontal, so think about when you look at the sunrise or sunset, and it's called the horizon, you're looking at it side to side. And then vertical would be up and down. In order to get an undefined slope, you would have division by 0. We'll talk about that a little bit more when we see the example of a line with an undefined slope. Our essential question today, how do we calculate slope and how do we graph without an equation? So first of all, looking at example 1, calculating the slope, and then we'll determine domain and range. We're going to revisit those concepts as well. When you're trying to determine slope from a graph, you want to look for where the graph crosses a nice coordinate. So I see one here at -3, 1, and then I see another one way up here. So we're going to count the rise and the run between those 2 points. So first of all, I know that my line has a negative slope because when I look at it from left to right, the line is falling. So again, that change in y over change in x, rise over run. So when we count the rise on this one, I see a change of 7. It's going up 7 from one point to the other. And then when I count the run, it's going left, so that's a negative. And that makes sense because my line is falling. When you simplify fractions with a negative slope, you move the negative to the numerator. Looking at domain and range, domain is the input, so we look at what x values are on the graph. So really what you're looking for when you trace the line from left to right is you're looking for any holes or any places where the graph starts or stops. That would be changes in the domain. Our line we could make without lifting our pencil, so our domain is all real numbers. The range are the y values or the outputs, so that's when you look at the line from bottom to top. And again, if we trace the line from bottom to top, there would be no starts or stops or jumps or holes, so we have a range of all real numbers. This time we have lots of nice coordinates that our line goes through, so I'm going to choose these two right here to take a look at for my slope, which is change in y over change in x. When I look at the rise of this line, it's not rising at all, but it does have a run, in this case between my 2 points, of 3. 0 divided by 3 is 0, so this is an example of a line with no slope or 0 slope. Looking at the domain of our line, tracing it from left to right, there are no starts and stops or jumps, so we have a domain of all real numbers. The range, however, if we trace it from bottom to top, it doesn't have any y outputs other than -3. So the range is y equals -3. What that means is, no matter what input is put into the function, the only output we get is -3. Taking a look at this line, it's got a positive slope. I can tell because my line is rising from left to right. So I'm going to try to identify some nice coordinates. So I see a couple here. Calculating my slope, change in y over change in x, or rise over run. Drawing that triangle between those 2 points, I'm seeing a rise of 1 and a run of 3. So my slope is 1/3. This line is similar to that first one, where from left to right, we can trace the whole line without starting or stopping. So we have a domain of all real numbers. And same thing from bottom to top. We hit all of the different y values, so our range is also all real numbers. Last example of slope on a graph. This time we're looking at a vertical line, still setting up our change in y over change in x. We're going to find two nice coordinates on this one again. Based on those 2 points that I found, we have a rise of 2. The line is going up 2, but it's not running at all. It has a run of 0. So what you want to think about when you're simplifying 2 divided by 0, I get a lot of students who want to say the answer is 0, but think about it as a multiplication problem. For example, if we had 8 divided by 2, we know that equals 4. Another way to say that is 2 times 4 equals 8. So for our problem, we have 0 times what equals 2. There is no solution to that because 0 times anything is 0. We can never get 2 when we're multiplying by 0. This is why this is what's called an undefined slope. Looking at our domain, when we trace our graph from left to right, there is only one input that we can put into the function. There's only one spot on this line where we have an x value, and that's x equals 4. Looking at the range, if we trace the line from bottom to top, we have all sorts of different y values to go with that x value, so we have a range of all real numbers.